Before we start shading scene objects, we should definitely have a look at the standard surface shader that ships with Arnold. So this is the shader we will be using for 99% of materials. So let's create one. AI standard surface. I've docked my node editor over here, just because it's a bit convenient. And let's rename this material test. And also rename the shading node, because it's good to keep it all tidy. So you can select objects over here. So we'll assign a material, and there we go. Now the standard surface shader is applied. Right now we can see that the surface shader is divided into the different scattering, like light scattering events or types or whatever you want to call it. I will go through them step by step and let's see where we end up. Some are more advanced, some are less advanced. Let's just go through. First of all, we have the weight of the base, the weight of the specular, etc. What we need to say about this is this shader is fully energy conserving. What does this mean? This means that there can never be more energy getting radiated of the material than was coming in. And this is one of the fundamental laws of physics, and in some shaders you have to balance this out yourself. For example, then it would be 0.5 here and 0.5 here, and that would then be, okay, this is still physically plausible. In Arnold, there is no need for this. Under the hood, it all balances it out for you, so you don't have to take care of that. You can go crazy, and Arnold will keep you in the physically plausible realm. Okay, so let's just go through them. Let's turn off the specular for now. First of all, we have a weighting on the diffuse, and then the color. Kind of speaks for itself. And we have the diffuse roughness, which switches from a fully Lambertian diffuse model to an Oren-Nayar model. This is a lot flatter, there's less surface definition, and is often used for very rough surfaces such as concrete, sand, etc. etc. Just leave it at Lambertian right now. And we have a metalness slider. It's kind of like a Disney principled BRDF inspired shader. So we have a metalness slider, which goes from a fully dielectric material to a fully conductive material. And this is, I don't know, it's very important, makes a big appearance change. Okay, so let's turn the specular back on so we can see what we're doing here. One thing to know is that if you turn on the metalness and you turn off the specular, you will still see a specular reflection. That is because in a full metal there is no diffuse component, and therefore the specular lobe takes the color of the base. This will determine the specular color in a full metal, whilst in a fully dielectric material, it will be the diffuse. So, why then is there a second specular option if we turn on the metalness? Well, this is because you have there's a thing as an edge tint to a complex IOR, and this is essentially to control the color of the edge tint. It's very, very subtle, but to create good looking gold and good looking silver and copper, etc., we need this control. So as you can see, it's just the way complex index of refractions are set up. Let's move on. There we go, put this back to 1 and turn the metalness down. And the rest kind of speaks for itself. You have a color to introduce some texture variation. We've got a roughness slider, which goes from a perfectly mirror-like reflection at 0 to a very diffuse reflection at 1. And the index of refraction. By the way, if we use a full metal material, the index of refraction does not count, because it works with complex index of refractions, which are set by these colors and then translated to some physical parameters inside of Arnold. So this is a very artist-friendly way of working with exact science. So with dielectric materials, though, you do have the option to increase the IR and also reach, like very metal-like appearances. But this is using the regular IRR instead of the complex IRR, and the metalness workflow is physically more accurate than this. So keep this in the dielectric range from, I don't know, 1 to probably 1.7 or something like that. 1.5 is like a plastic. Okay, so there's that. Then we've got the anisotropy, which is used to make brushed metal in certain cases. It's a bit too, or it's not used so often, so I won't go into it now. If you do want to learn about this, you can look it up in the documentation. Then we have the transmission. The transmission is the same word as refraction, so it's just the word Arnold prefers to use. So this is now with transmission weight 1. We see that right now there is no diffuse component anymore, and this is grayed out. It doesn't quite look the way we would expect to do, though, and that is because Arnold still thinks it is an opaque object. So what do we need to do for that? We need to select the object and go into the object's shape node. And over here there is an opaque checkbox. For any kind of transparent material or refractive material, or just anything that you can kind of like see through, you should disable opaque. And now Arnold knows, okay, I need to use a different set of calculations for this. In these Arnold attributes and the shape node, we'll get back to them a little bit later. There's some important ones such as the subdivisions and the displacement attributes. Okay, so let's move forward with this. The transmission IOR does not have, or is not exposed. So why is this not exposed? Because in physically plausible materials, the index of refraction will always be the same as the index of refraction of the specular scattering event. So if we adjust this in the specular tab, it will also be changed for the transmission. We do, however, have the option to provide some extra roughness just to have artistic control over it. So we've got a color, we've got the depth at which the color is realized. So if we take, for example, a light blue, which still looks very saturated over here, and then increase the depth, we can kind of see the depth at which this full color is realized. And then scattering, which is used for example, milky or like troubled water, like dirty water, for example. Then we've got the anisotropy again, which in this case is how much light scatters forward and how much light scatters backwards. Examples of this, or good examples of this, are in the Arnold docs. Then we've got the dispersion. The dispersion is the splitting of light into its different components. Essentially, why does this happen, right? Diffraction and dispersion happen because the index of refraction is not the same for all wavelengths of light. And the Abbe number is a measure of that, named after a scientist called Abbe, unsurprisingly. So it creates a lot of noise. I personally don't use this very often unless I really know what I'm going for, but it creates a dispersion effect, which is cool. So then the transmission, we're going to the subsurface. This is grayed out at the moment because we have transmission on. So in the subsurface, we can turn this on. Okay, so the subsurface color right now, or in the weight, if we use 1, then the diffuse will once again be disqualified. So it will not matter. So in a full subsurface model, let's say we want to create a green slime or something like that. We would go and set subsurface color, then the radius. This is an RGB weighting on which colors of light scatter deepest. So it's kind of finicky, but you get used to this. There we go. I'm going to increase my subsurface samples. Did you see what I'm doing? And then the scale is just a global scale on the subsurface depth. If we, for example, the radius, if we make it lighter, then the light will scatter further in, and this just acts as a multiplier on this. Can go really crazy with that. Okay, so let's turn this back on, and let's turn the diffuse component back on. Then we have a coat. So a coat, this is like an extra layer of an extra specular layer, which goes on top of the other ones. We do have to note that when, for example, you use a normal map or a bump map, this layer will not take the bump map of the first specular lobe into consideration. And this is used because often we would vary the bump on this in, for example, a car shader or like a car metallic shader, and then another gloss layer needs to go over it, which needs to be much more perfect, and that's used for this. For example, if we turn this on, you can see that we add in another spec lobe. We have different IRR controls, and of course we could also pipe the bump of the first spec lobe into this if we want to. It's just by default that is not the case, so we have a separate control for that. And emission, there's not many scenarios where you use this, so I'm not gonna go into that. Then we have a thin film. So a thin film is a layer of oil that is on top of a model, for example, and it is so thin that that is thinner than certain wavelengths of light. So what this kind of simulates is the color patterns you found on oil stains, on soap bubbles, etc. So if you just enable this, let's have a look at what it does. Look at the specular. It's hard to see, but you will see variation in the based on the angle we are facing the model, on the facing ratio. If you would want to break this up a bit more, which would be the case in, for example, a soap bubble, because the thickness is in some places on the bubble is a bit thicker than in others. So I would, for example, pipe a noise into this, and then you get a much more realistic appearance. There you go. Now you can see what it actually does. I guess through useful, for example, also when you do animal skin, for example, beetles, etc., etc. Then there's a geometry tab. I'm going to turn this back off. Once again, for the soap bubbles, if surfaces are incredibly thin, then you can use the thin walled over here. I'll show you what this does. Let's say we enable transmission again. To the test material, put this back to white. Okay, so then, for example, the thin walled will simulate this model actually having a thickness on the edge, but which is negligible. So super thin, and it's useful for soap bubbles. Again, there's more information on the website. Usually don't take this for realistic, for most of the realistic objects. And we have an opacity slot to for the opacity of the objects, useful for example, cutting out leaves on cards, and a bump map, and the anisotropy tangent, which is too advanced to discuss right now. We also have an option to create mats for this. We'll leave that because we'll create cryptomats. And then over here in the advanced section, just leave this to what it is. There's an option for caustics, but Arnold and caustics are not really the best friends due to it being a unidirectional ray tracer. And then we have options to cheat the amount of indirect diffuse. You can push this beyond 1, for example, cartoony stuff. And that's it. So it's pretty basic. It's pretty heavily inspired by the Disney's principled BRDF.